stressed. I've been trying to grow plants, but nothing is working. I've changed the fertilizer and all, but they still won't grow. And it's been 2 weeks with no progress. What should I do?
What about the soil? Have you checked the condition of the soil? Maybe it's infertile or the pH level is too acidic. Maybe you should try sampling.
So, what is sampling?
First and foremost, what is sampling? Sampling is the process to get a representative and homogeneous sample from a whole batch to be taken to the laboratory for analysis. Why? Because analytical chemistry often deals with large amount of materials, so sampling allows the analysis of a smaller portion. No matter how precise the analytical techniques are, a poor sampling can lead to inaccurate results. A proper sampling method ensures that the analysis shows the properties of the whole material, making it essential for producing reliable data. Now, let's look at the theory of sampling. According to the International Union of Pure and Applied Chemistry, IUPAC, a sample is a portion taken from a larger amount of material. Sampling includes all the steps taken to collect the final portion that will be tested. It starts with collecting an increment. What is an increment? It is a small amount taken in one action using a sampling tool. Several increments then make up a primary sample, which is then reduced to a smaller size called the laboratory sample for testing. To get accurate results, the test sample must represent the original material well. A statistical sampling plan helps guide how to choose, store, and prepare sample to reduce differences between the test results and the true values of the material. In short, sampling is a crucial part of chemical analysis and not just a step before testing.
Oh, that sounds interesting. How does it work?
Let's take a look at the methodology of soil sampling. Firstly, the field that we want to take the sample from must be surveyed and divided according to the size, slope, color, and crop. The size of each farm should not exceed 1 acre. If the whole field is very uniform, then only one representative sample can be made from 1 hectare. Next, any surface vegetation should be cleared, and then a soil auger will be used to start the sampling. The soil auger should be positioned at a 90-degree angle to the soil surface. The auger then will be rotated clockwise, applying downward pressure until the sampling cylinder is full. Lastly, the samples from 6 to 8 located marks will be taken. All the samples taken from the field should be kept in a clean cloth or polyethylene sheet and mixed very. This picture shows the coning and watering method. It is a method used to reduce the size of powdered samples while maintaining the representative sample for analysis. Firstly, the soil should be mixed and coned. Next, it will be flattened for quartering. The flattened cone then will be divided until 4 quarters, and then the opposite quarters will be taken to form the reduced sample.
There are some applications of soil sampling in real life. Actually, soil sampling is very useful for gardening and home agriculture to actually determine the pH of the soil. This is to allow plants to grow in optimum condition. This is also because some plants can grow in soil that is too acidic or too alkaline. So, for example, for plants that grow in acidic soil, we have blueberries, gardenias, and magnolias. And for plants that grow in alkaline soil, we have lilac, Japanese barberry, and cabbage. Next, soil sampling is also very important for farmers. This is because it provides vital insights and nutrients level, enabling informed decision about soil fertilization, crop selection, and overall soil management. This actually helps to optimize the crop yields, minimize fertilizer costs, and protect the environment. Next, we have the construction industry. Soil sampling is actually very important to the construction industry to determine the suitability of the soil for supporting structures. And it is also important to identify potential issues that could lead to instability or failures. By doing soil sampling, engineers will be able to design appropriate foundations, minimize risks, and ensure the long-term stability of the buildings. And lastly, we have the environmental monitoring. Soil sampling is actually very important to identify the contamination and organic water content. For example, we can know about the soil fertility and water retention, which is how well the soil can hold water. Soil sampling can also identify the microbial diversity by the nutrient cycling. And lastly, soil sampling is very important to carry out erosion assessment to analyze soil structure and texture to identify areas vulnerable to erosion.
So, here's some questions that you guys might be wondering about. Digestion is an important step in analyzing solid substance like soil. But what is the difference between wet digestion and dry digestion? Wet digestion involves a high water content, while dry digestion operates with a lower water content. Dry digestion requires less water and it is more efficient for certain waste types. And it can also handle a wider range of substrate, but it may have lower degradation efficiency. Wet digestion, on the other hand, is more established for smaller scale application but requires larger reactor volume due to the dilution. Next, the digestion process at high temperature could produce a larger precipitate and reduce contamination. Discuss this statement. Heating a precipitate in its solution at high temperature can lead to larger pure crystal and reduce contamination. This is because at higher temperatures, smaller particles of the precipitate are less stable than larger ones due to their higher surface energy. This causes them to dissolve and redeposit onto the larger, more stable crystal, leading to their growth. This is the process called oswald ripening.
Soil sampling is a crucial step in soil analysis to ensure the accuracy of the data about soil properties. A well-planned sampling process should be taken to make sure the actual condition of the entire field or area can be presented. Proper techniques such as taking samples at the correct depth from multiple locations and avoiding contamination are very essential to ensure the reliability of the result. All of those things are really important, especially when it comes to making informed decisions in agriculture, environmental monitoring, and land management.
Oh, really? Thank you guys. I will try that later.